We'll go ahead and get started on the theory portion of what's coming up next, which is dealing with authentication. Now, a little bit of this, we've already done, which is on our back ends, we've provided a way for users to log in. And so we've created a registration system. And so when we're talking about, the topic of authentication, we've already dabbled in this. What we haven't done is set up our back end to persist logins, right? And so we're going to talk about what does that take, as well as just dive a little bit deeper into the process of authentication. And so right now, again, we're not persisting logins. We're basically having to re-log in the user, and so if the user right now, if we had a front end, which we don't, but if we had a front end, to give you an idea of what this would look like, the user would close their tab and then the browser would forget them, right? Some websites, as you guys know, I could go to, for example, I could go to Facebook right now on my browser, and Facebook would auto-authenticate me, or it would auto-authenticate me. It would just let me in. I wouldn't have to provide my username and password, right? Some websites, such as banks, make you authenticate every single time for security purposes. Others, like social media, do not. Right? So depending on your website, your backend may have to remember or persist your authentication credentials, if you will. Okay? So that's what we haven't done yet. And so that's what we're going to kind of learn, and there's going to be a couple of tools that we're going to learn about to do that. Okay? So if we kind of look at our objectives, implementing a login, we got that part, right? We implemented a user login. However, we have not really implemented a session. Okay, and that session is essentially the client and the server remembering one another, if you will, or setting it up so that the client doesn't have to re-log in. So a session is what we haven't set up on that half. We've already salted and hashed our passwords, so they're not stored in plain text, so we can check that one. Check our passwords against previously hashed passwords. So that's bcrypt 2 and 3. Our bcrypt, I kind of jumped ahead of the curve on that one because why not? So we already took care of that. Number 4, use what are called JSON web tokens. Use these things called web tokens to generate secure login tokens, which are cryptographically secure. We have not done that, and we have not issued cookies to the client. So these are two tools, be it cookies and JSON web tokens, that we have not dealt with on the back end yet, so we're going to get into that. Then reading cookies, reading authentication headers, authenticate tokens, received via cookies. So I guess the thing I would say, kind of off the top, these things called web tokens, JSON web tokens, and cookies are basically working together. Okay, so you're going to create this web token and store it in a cookie. That's basically the way it works. You're going to create a web token, store it in a cookie. These two things are going to work together to basically remember that you've logged in successfully and you don't have to log in again. Implement application-wide authentication middleware. This one right here, this is really interesting. Implement application-wide authentication middleware. I want to do something this time in this class that I haven't done before completely. Okay, what I've done in this class is we essentially write our own code to handle application authentication, right? We write our own code from scratch to handle authentication. However, there are libraries out there, such as Passport.js, that frankly I would almost expect if I'm taking a class on MERN, right? I would kind of expect that you would learn how to log in with your Gmail credentials, right? How many websites log in with Facebook or register with Facebook, register with Gmail, you know? Take these other authentication platforms, Facebook, Gmail, they're storing your credentials, but you can use their login system to register with our site. So that's what Passport is. And so we're going to do both this time. Okay, we're going to do both, creating our own, and I'd like to implement a package out there called Passport that I'm just going to cover that material with you guys. And it'll be a learning experience for me because I've done it up to a point. But you can kind of see there's a bunch of authentication strategies. But here, sign in with Google, sign in with Facebook, right? So using these other platforms that are not just a homegrown solution, which is what we do. And then we're going to be working with cookies and what are called auth headers in Postman, and then we're going to kind of lock it down. If you are not authenticated to our system, you are not going to be able to do certain things. Okay, so step one is learning how to make the login system and making that login system persist, right? But step two is, okay, once we know who you are, let's actually perform the useful operations. Okay. So what is authentication? You all should more than likely, if you're drivers, you have a form of authentication in your wallet or your purse, right? It is proving you are who you say you are, right? So state IDs, driver's license, your government passport, right? Your government passport if you're going to travel internationally. These are all forms of proving you are who you say you are. In the digital world, servers have what are called digital signatures. These digital signatures are a form of authentication, right? It's a piece of software that proves a server is who it claims it is. So this is a server for whatever.com website it may be hosting. So again, authentication is a process of determining whether someone or something is who it declares itself to be. Some forms of authentication, right? Most simple form, and the form that we'll be implementing is a login form on a website. So very simply put, right, username and password. But there are a lot of others. In fact, there's a brand new one that's not on this list that is on the tip of my tongue. But if we just think about authentication, username and password, or email and password, right? Kind of an interesting difference there. Some websites, they require your email and your password. Some require a made up username and password. Some might require a cell phone and password. Some, it'll say enter your username, email, or cell phone, right? Some websites, they just kind of give you that flexibility. What about when you're paying for something, right, with your credit card? There's a lot of information to make an online payment to authenticate that you are, an owner of that card. You are who you say you are. You're the owner of the card. You got a credit card and maybe a PIN, right? You think of the gas station every time you go and you run the debit system, you got to put in your PIN. Sometimes you need a credit card number and a specific chip, right? So 5 years ago, all credit cards started having chips, which made them more secure. By the way, with these chips, I don't know if you guys remember, like in the old days before credit cards had chips, if you would go to Target and you give them your credit card, like your credit card would be saved to their database, right? So every time a customer would use their credit card on a Target, purchase without a chip, it was saving credentials, it was saving credit card number and PIN codes in a credit card database for Target. Okay, severely insecure is storing all that information in one place. I don't know if you remember, I remember Target got hacked. All that information was compromised, okay, and that was a big loss for Target. In other words, they got sued and they had to spend a lot of money, because they basically did not secure customer information. Now with the invention of these chips, that's why these chips are now required 4 or 5 years ago. They now basically encrypt, I don't know if they encrypt the number or they encrypt the PIN. Basically, it's a one-time use code, right? So you can no longer, Target no longer has to save everything that's required to make a purchase. This chip is like a one-time use code, and it basically makes it more secure. I guess that's the short version. Credit cards with chips, more secure than credit cards without chips. Okay, and not by a little bit, by a lot of it.
The chip kind of like just an ID number that necessarily needs the other stuff. They store the ID so they know.
Yeah, it generates a one-time use code. So like if I purchase gas, right?
How does the chip know that? Does it when the processing, the car company sends back a error?
Yeah, I don't remember off the top of my head. It's a good question. I don't remember off the top of my head. There's a lot of smart people behind this technology. I don't remember off the top of my head. Okay, point is, all these different pieces of information, if you think about, this is all stuff that we know, and that stuff that we know is one way to authenticate yourself, right? This is all stuff that we know. The CVC code, your signature. Smartphones use PIN codes, they use patterns, fingerprints, but then there's also a form of authentication about who you are. Right, so there's biomarkers, there's face unlock, there's fingerprint unlocks, there's badge cards, right? You all badged in to get into the building, right? So this is about who you are, right? So some forms of authentication is about what you know, and that's one mode of authentication, username and password. And then there's some forms of who you are, such as facial recognition. Okay, so here's, again, knowledge, something you know, possession, something you have. A lot of machines in government, they make you have like a key fob, right? So you literally have to have essentially a USB device, and if you're going to use the machine, you have to plug that USB device into the machine. It's very similar to your, to your badge, right? You have to have it to get into. To get in. So secure buildings, you have key locks, you have combo locks, you have keypads, biometric locks. Again, this is what magnetic cards, this is what we use to get in. RFID cards. These are all forms of authentication. Again, knowledge, what you know. Possession, something you have. Inheritance is something that you are. You inherit your facial pattern, or you inherit your fingerprint from your genes and your parents. Location is where you are. And so you guys have all probably seen this in the sense, like, if you go to log in from a new machine on Google, it's going to say, hey, I haven't recognized this machine before. Maybe you're in a different state, or you're in a different city, you're at a different IP address. I notice if I go to use my credit card, anybody ever had this happen? You go to use your credit card in another state, and your bank's like, wait a minute, like, why are you in Japan? And so your bank will flag as a potential safety concern, like your location is not the normal location, we're not sure that this is you, right? So that's a good example of where you are. Is your bank will flag a credit card transaction of like, why is this going on in the Cayman Islands? And behavior, how you act. More and more today, websites are using two-factor authentication. It's like, hey, not only give me a username and a password, but we're also going to text your phone, and you have to have that phone device, right? So that's something you possess. So you're going to use two factors. You're going to use a knowledge and a possession to prove you are who you say you are. So again, simple forms are knowledge, username and password. Credit cards require knowledge. Lock screens may require knowledge of a PIN. Lock screens may require inheritance, such as fingerprint or facial recognition. Many buildings require possession. Your car requires possession. You have a key to open it up and drive it away. However, one-factor authentication mechanisms are insecure for most modern applications. You also have authenticator apps. Raise your hand if you have an authenticator app on your cell phone. 1, 2 of you? 3? What authenticator apps do you have?
It's like Microsoft or whatever.
I got the one for our Franken office account.
Okay.
You could set it up either with the phone number or the app, but it like kind of hides the fact you can do your phone number. You have to
I
press
just have an authenticator.
Is that the Google
Yes, the
Authenticator?
No,
Yeah.
it's the Microsoft one for our inside Rankin accounts.
No, mine. Mine is the Google Authenticator.
Yeah, I think Authenticator itself, it's this little icon right here. I'm looking at it on my phone. If you open up Authenticator, yeah, it's Google Authenticator. There might be other apps that are similarly named, but you know,
What does it look like?
it looks like all the other Google Gmail apps. They got
Looks like an asterisk, but the coloration's like
the colorations of Google
Yeah.
products.
I mean, Google sends it to my phone whenever I log in on a different device. That's kind of just pre-installed.
So again, it's a little annoying, right, to most of us that everything requires two-factor nowadays, and every website you're logging in using multiple. There is a new technology built into Chrome that is trying to get rid of websites using username and passwords. And I'm trying to think, it's been a push in the last year that you authenticate maybe to Windows once and then you're auto-authenticated to your websites. You guys know what I'm talking about? Am I barking up anyone remembering this? Let me pause, see if I can. So just kind of intriguing new thing that's around the corner that I'm just throwing out there because I've read a little bit about it. There's this technology called passkeys. Passkeys are digital credentials that allow users to log into websites and applications without a username and password. They are based on a fast identity online standard and are designed to be more secure, faster, and easier to use than passwords. Passwords are inherently insecure, right? Because people are terrible at remembering them. It's like the universal problem, right? The universal problem is that it is hard to remember your passwords for the hundreds of websites that you use. Therefore, you use insecure passwords or, password managers. Yeah.
How do you log into this, though? You need a username and password for this anyway, it kind of defeats the whole purpose.
Yeah, let's see. So the beginning of the end of the password, right? For the first time, this is Google. For the first time, we've begun rolling out passkeys, the easiest and most secure way to sign into apps and websites, a measure step towards a passwordless future. Okay, we don't need to dive deep into this. I would encourage you to read more about it. I don't know enough, okay? But this is, again, safe to say this is Google pushing this out. There's a lot of smart people out there that are trying to find a solution to the problem that we are terrible at remembering passwords. So their claim is a simpler and safer alternative to passwords. And it's not just Google, it's Google, Apple, and Microsoft. So again, not just
Apple's
one.
actually working with the other two.
Pass keys are a new way to sign into apps and websites. They're easier to use and more secure than passwords. So just something to look into. I don't know. I've seen it. I haven't really dived deep at all. Okay. For now, we're using passwords as one potential solution. Okay, back to two-factor authentication. Some login forms may check your IP address. So that's one. We talked about that. Some login forms send a text to your phone. Credit card readers are using chip. Some credit card readers are using tap and pay. We talked about a lot of this, but the idea is that you need multiple, right? A lot of these are the same things we already talked about, but you're requiring multiple. There's a section in here about hashing your passwords. It's something that we're already doing using bcrypt. Hopefully you guys understand the benefit of taking something in clear text and hashing it so that even if you're a database administrator, you cannot read a user's password because, well, that's insecure. So when it comes to hashing, the term hashing is just taking something known to something unknown. Really, that's what we're doing with hashing. You can write your own algorithm to hash like an input number and output an unknown number, right? So in the early days of hashing, if you study security, hashing goes back thousands and thousands of years where they would take a piece of paper, and instead of writing a clear text message on that piece of paper, they would write an encrypted message. You just had to have the key and know how to decrypt that message. So in one city, someone would write a letter, and they would write it using this kind of hashing algorithm. They would send it with a messenger. The messenger couldn't read the letter because it was hashed, it was encrypted. And then someone on the receiving end in another city with that same key, if they understood how the message was hashed, they could unhash or decrypt that message. And so there's all sorts of hashing algorithms that exist to encrypt numbers, and then you have to understand the algorithm so that you can also decrypt that message. And so there are some algorithms that are out there to encrypt and decrypt passwords. The more popular MD5 hash, maybe you've heard of MD5 hash. In fact, I know you've heard of it because in the C# class we used MD5 hashes on some of our tests in our labs and things like that. But these are kind of increasing security, and really the more secure than MD5 would be SHA-256. So SHA-256 is kind of the gold standard, the common standard for hashing algorithm in 2023. And so in this list, SHA-2 is the only one that's considered secure enough for passwords. MD5, they've called that insecure since 2008, and SHA-1's been considered insecure since 2010. Keep in mind, anything that can be encrypted can also be decrypted, so nothing is completely secure. we use a tool such as bcrypt, and like the big takeaway from bcrypt is that you can slow the hackers down. You can slow the hackers down so much that it is basically not worth their time and effort. Okay, even if they have the most powerful computers, you can really slow them down quite a bit. And of course, the argument then is made, well, what if they have the most powerful computer in the world? What if they have a quantum computer? Then, okay, then, maybe, again, nothing's ultimately considered completely safe.
What if they have multiple computers?
Well, I think bcrypt can slow down multiple computers. And with this bcrypt, if you kind of get into it, this takes two inputs on the hash function. You take the unencrypted password, so you got the string, if you will, but you also have this thing called salt rounds. And salt rounds is a balance. This is a number that will take a fast computer and really slow that fast computer down. So I commonly use the value of 10 for the salt rounds. But if you use a number that's too high, let's just say use 100 or 1,000, then it'll slow down performance of your application, because of course you need to be able to use this hash password to get it back and determine if it's correct or incorrect. So this salt rounds is the input to our hash algorithm that is used to increase the difficulty of hackers trying to hack our password. And you guys remember using bcrypt, and this was on the way in, right? Hashing or encrypting the password. And this is an example of bcrypt.compare, where we were basically decrypting the encrypted password against the hash, or the secret, if you will, to check a password to determine if it's correct.
Quick question: if bcrypt can do it so quick like that, why can't a hacker just use compare and run a bunch of random passwords there?
Well, they have to know your secret.
The
Your
hash.
secret is the hash, right?
Yeah, but if they have access to it,
That's like it. That secret, we stored it in the .env, right? So if they were able to gain access to that file, then they would, right? So you're right. If they have the secret, then they could use the same code that we do. What is that secret? Well, that secret is its own password. So yeah. The next part of this lecture goes over what I find to be a really interesting topic, hopefully you guys do too, is this concept of internet cookies. And without a doubt, you've heard of internet cookies. Hopefully you have a general idea of what they are. But generally speaking, they are text files saved with information in them on your computers. And these text files can be transmitted to the servers hosting our applications and our websites. And so cookies store information about you, about your browsing habits, about who you are, etc. Because they store information, they are the main way that online advertising has been done historically. So when you go to a website, they collect information about you, and then they can sell that information to other websites, right? If you've ever heard of that concept, that's a concept called third-party cookies. That is how you are tracked on the World Wide Web or on the internet, right? You're tracked through these cookies, these text files storing information, and then they're selling them to Facebook, they're selling them to Apple, they're selling these websites are selling this information that are collected on cookies and transmitted to their servers and stored on their databases. They sell your information to Facebook or whatever. Okay, so that Facebook could use that information and advertise. Okay, how many people, raise your hands, how many people have either heard someone say or said it yourself that my phone is listening to me? Raise your hand if you've heard someone else say that or you've said it yourself. My phone is listening to me. Almost everybody has either heard that or said that themselves. Okay? A real life example. On Saturday, I'm out with a friend. Okay? And we're talking about the war that's going on, Israel-Palestine war, right? And we're having a conversation about it. And we're just discussing like the history of this conflict, because there's a long history going back to World War I believe, okay, about this conflict. And so he goes on his phone, he does a Google search to understand the history of this war, okay? The next day, he's on Facebook. He sees a Facebook reel talking about the history of this war. And he goes, see, another example of my phone listening to me. And I said, did you forget that you did a Google search and you clicked on a couple of websites to try and understand the history of this war? That is a perfect example of someone who does a little search. In that search, cookies are created. Cookies are then sold to Facebook, who's then going to give you the content that you're trying to find the answer to, right? That is a perfect example of any time someone says, my phone is listening to me, who someone completely forgot or they don't understand that they did a Google search, they clicked on a couple of links, without a doubt, information was stored about those searches and sold to Facebook. Okay? So
sometimes you do think it's actually listed.
people do think that, but they don't understand the technology behind it that's enabling that.
Even if
right?
you don't do a search sometimes, even if you don't even
People forget they do a search. Now, is it true? I will tell you, I can tell factually it's true. If you do a voice search with your home assistant, they are recording your voice. I can go back to my voice commands on my Google Smart Home, and they record every command you give it for for improvement, right? They're trying to improve their results. So sometimes you're right, they are recording, but you give consent. At some point you click on it. That's a whole nother conversation. But yes, some people do believe that they're actually listening to them. I would argue that there's probably a search that they've done in their past,
But why did it bring it up now when I did it a year ago? It's really what it is.
Well, they're pretty smart. That's the thing about these algorithms, that they're pretty smart. Maybe it's a yearly search. Halloween
I
costumes.
mean, Google does tell me call my mom as soon as I get to the cook gate on Sundays.
Yeah. So just upon a Google search, how big is digital advertising? I just want you guys to kind of see this number. And people don't understand how big this number is. Online advertising is $600 billion. Some of the largest companies in the world, such as Meta, operate because of this advertising. Yeah.
So the website that has the cookie sells it to the...
Yeah.
Is it like instant that they sell it, or is it like, how does that work?
Yeah, I don't know the communication process. I'm sure it's different. I'm sure the answer varies there. You go to a website on your computer, and then you go to Facebook. Facebook now has access to that information on your computer, right? The cookies that were generated so as instant as it needs to be, right? I think that is one workflow that it's not like they're saving it and selling it in like batches, but it's like, hey, you went to the website on your computer, now you go to Facebook, and Facebook has access to those files because, again, at some point you clicked I accept, and so that is one workflow. Yeah.
So, when you click accept, how long does it like actually last? Until you like clear the cookies and
Okay. So you're asking about accepting a policy?
say you like accept cookies or whatever.
Yes.
How long does it actually track for and literally until you clear it?
Yeah. So let's talk about. I'm gonna get to that in a little bit, if I can, because there's a little bit of history there, and I'm gonna go through that real quickly. And I'll think about how I want to answer that. But okay, so this is big business. This is big business. This business of online advertising. But it says, but the cookie is dying in response to privacy concerns. You know, they're talking about getting rid of third-party cookies in their web browsers. You know, anytime that you kind of destroy the tools that these companies are using to track you, that takes big blows to their bottom line. Like they're not able to make as much money off of us. Nowadays, okay, there was a huge law that was passed in Europe, right, the EU. Okay, there was a huge law around cookies because a lot of people take their privacy seriously. Okay, and Europe is known for being more extreme, I guess, generally with their privacy concerns than America. Okay, and it's one thing when you and I are browsing the web and they're selling information about us, but even considering like some of us have kids, right? And when your 8-year-old is browsing the internet and, you know, doing things online, giving their information online, and essentially someone's writing down information and saving it about your 8-year-old, you know, people can get a little defensive, right, about their privacy. And so Europe passed a law years ago that when you would go to a website that was hosted in Europe, you had to then accept their cookie policy. Okay, before this law, you would not see those little pop-ups on websites that would say accept the cookie policy. Okay, this was a banner law. I mean, it was huge. This GDPR, I think that's the short name for it. I want to say it's been around for 4 or 5 years. Okay, this law, which was a big law in Europe, has trickled into the United States. We have not passed a law like this that I know of nationally. We don't have any sort of national law, but state by state, some states have started to implement their own laws similar to this. So that again, wherever your website is hosted physically, wherever your server is physically, I want to say California has done this. If you have a web server hosted in California, you must give the user that little pop-up box that says accept all cookies or deny. Okay, now Jacob's question was how long does it last? Okay, and it boils down to cookies do have expirations on them. And it is completely up to the developer to set that duration. Okay, each website decides how long their cookies last on your computer. Okay, and I think that's ultimately what you were asking, right? It can be anywhere from 10 minutes. So like a banking website might create a cookie for a very short amount of time because it's high security, lots of money in there, right? And they don't want to keep you logged in at all, right, for any more than they need to. Other sites like social media sites, I mean, they're benefactors of these cookies, and they're going to, have probably a very loose or lenient cookie policy, and their cookies are going to last for as long as they can, right? Does that make sense? And so I hope I answered your question, because your question is, well, how long do they last? And it is on a per site basis. And you get the answers to that if you actually read the stupid cookie policy, but no one ever does unless you're a lawyer, right? I mean, have you ever read a cookie policy? Right. No one reads them unless you're a lawyer. So, this Forbes article is, saying that they're slowly dying, and it is because people are slowly becoming aware of the privacy concerns, and people in Congress are pushing back on it a little bit, but that kind of stifles technology, right? Big companies, I would say, it stifles big companies, right? So it hurts their income, it hurts their revenues, and so it is a slow death of the cookie because America is known for being pro corporations and big companies and big tech, and we don't want to stifle our big tech, right? Because then China might take over as the leading technology, or Russia or some other country that's more friendly to tech, right? Might take over as the leader. Okay, so that's just a little bit about cookies and their importance. Cookies are big business because of advertising, and what a cookie is just a piece of information about you that can be sold, and to other sites. And if you've ever heard this, maybe you've heard this, maybe not. But like Facebook is free, right? And so if there's no cost to use the product, they say that you are the product, right? So you are essentially being sold. Your information is being sold, right? If you've ever heard about that. So you do not need Node to create cookies. Okay? In vanilla JavaScript, you can create cookies in vanilla JavaScript. Okay? You do not need a dependency in Node to do this. However, that's how we are going to create cookies. Okay? We're going to install a dependency that's going to help us write this code right here. So this code right here, we know the RES is the response object, right? And the dependency we're going to install is going to attach a method to the response, right? To send a cookie to the client called theme with a value of dark, and this third argument, right? So this res.cookie, look at this as 3 arguments. Argument 1 is a string. What's the name of your cookie? String 2 is what is the value. And object is, to Jacob's question, how long does this cookie last? Okay, 1,000 is 1,000 milliseconds. So this is 1 second times 60 is 1 minute times 60 is 1 hour. Right? So this is almost needless math to say make this last for 1 hour. Okay? It's a little bit better to put some numbers in here so you can figure out, like, versus just having some big number there. What is 1,000 times 60 times 60? I don't know what that is. Right? It's a big number, but this is a little bit more understandable if you put a little math in there. So this is how to create a cookie in Express, and we will create cookies in Express, and we will, once we create a cookie and we can send that cookie to the client, then we can then later retrieve that cookie. Okay, how are we going to use cookies? Cookies can be used in different ways. We're going to use cookies to create sessions. Right? If anyone's taking notes, and I think some of you are, if anyone's taking notes, we are going to create cookies to create sessions. What are sessions? Go back to HTTP. HTTP is stateless. What does that mean? What does it mean when I say HTTP is stateless? What I mean is that there's a relationship between client server, and they tend to have amnesia. They forget about one another. Okay? The client says, give me something. The server gives them those resources, and then they forget about one another. Okay? They have amnesia. Clients and servers don't remember one another. Every request is like, I've never met you before, client. If I'm a server, I've never met you before. We could have talked 1,000 times before, but I don't remember you. If all you're using is HTTP, which is a protocol of communication across the World Wide Web, okay? HTTP is stateless. creating this environment where client does not remember server. So in this event where you authenticate with a server and you close the browser and then you open the browser, you go back to the website and you want to be logged in, the server's not going to remember you because HTTP is stateless. Okay? If we want to create this where our credentials persist, which we don't have right now, if we want our credentials to persist, we're going to transmit them in cookies because cookies go back and forth between client and server. They're little files that can be stored on the client. Okay? And yes, cookies are big business about storing your private information, but they can also store authentication information. Okay? And they commonly do store authentication information. Okay? So cookies, if you're taking notes, cookies are used to create sessions between client and server. Because HTTP is stateless, we need cookies to remember one another. We no longer have amnesia, right? Client servers no longer have amnesia when they can use cookies. The problems with cookies is that you can't encrypt the data very easily inside of them, right? So we use another tool that'll help us create a more secure mechanism of dealing with authentication and credentials and things of that nature. So cookies, and I'm sure this gets into this. So by the way, the package that we're going to be using is called Cookie Parser. Okay, Cookie Parser will enable us to write this code to create cookies and read cookies. Okay, sending them back and forth, client and server. Okay, so we need this Cookie Parser, very simple, npm install Cookie Parser. Okay, you guys are very familiar with installing packages now from npm. So we're just going to install Cookie Parser, and yes.
So if we didn't install that, like you were saying, we could just do it flat out in JavaScript?
You could, yeah. So
It's just harder, I assume.
yeah. So why? That's a good question of why use Cookie Parser. And I suppose it streamlines it. Yeah. So your answer is, I think you're correct. This would just make the amount of code that we have to write go down. And so this would streamline it. Yeah. Okay, so we're going to install Cookie Parser, and then we're going to import it. Now, this is a middleware. Cookie Parser is a middleware that anytime you see app.use, right, we're going to bring it in with an import, right? We're going to bring it in with an import. We're going to use app.use, and this is going to be on our server.js, and this will allow us in Node to create cookies. And then if you want to, you can install a client-side plugin in Chrome called Edit This Cookie, and it'll allow you to kind of see what cookies are being, I got this right here, Edit This Cookie. It allows you to look at the cookies for that individual site, which I think is kind of interesting outside of this class, like what cookies are being saved about me on this site. This is an easy plugin to install. That can tell you some information about that. So kind of a cool plugin. Okay. So again, the two things that we're going to be used to create sessions, we're going to be using cookies to create the sessions, and then we're going to use this other technology called JSON Web Tokens that's going to secure the information in our cookie. So cookies are inherently unsecure because they're saved on the client and they can be modified. I just showed you this plugin where you can edit a cookie on the client. You don't even have to be a developer if you know how to use this cookie. You can save information, you can modify your cookies, and then send different information back to the server that is fake. you can send bad data back to the server. So cookies by themselves are not secure. This JSON web token uses cryptography, right? Just very similar to bcrypt. Bcrypt for logging in users and hashing passwords and decrypting passwords. JSON web tokens, you can take information and with a hashing algorithm, you can encrypt that information and save it inside of a cookie in a much more secure format. Okay, so if the way I think of this is cookies is for sessions, cookies are for sessions, web tokens are to save your what are called, well, they're called authentication tokens. We're going to take your authentication tokens and encrypt them. An authentication token is like, hey, you have provided valid credentials, right? So you take these web tokens, you encrypt them, you store them in the cookie, and these two things work together. And that's what we're going to be doing, right? Cookies for sessions, web tokens for security, and security of your authentication token. So if I'm, highlighting this, used to secure your authentication token. A token is just like a token is that. It's a thing that says you're authenticated. You have provided authentication. So that when you go back to Facebook, like you close Facebook, you don't have to re-authenticate. If you have a token, you're in. Oh, it knows who you are, and you don't have to re-authenticate. You've already done that if you have an authentication token. Everyone with me there? Right? An authentication token's like, hey, you've got this thing, you've got this token, you don't have to authenticate again.
Do the tokens expire?
The tokens expire. So the cookies can expire and or the tokens can expire. So there's kind of like two expiration dates in here that we have to consider. All right. Cookies, again, stored on the client. They're editable by the user. There's got to be a joke in there about cookies being almost editable, close enough. Both back-end server and front-end client can access your cookies, and they do transmit back and forth a lot. So it's like sent to the server with every request until it expires or is deleted. And there's a little frowny face there if you can kind of zoom in there. And the reason that's a frowny face is that's networking traffic, right? The client will send their cookies to the server every time until that cookie no longer exists. Web tokens. Again, this is the security side of the house. We're using cryptography to secure the token. Again, the token's like, hey, they've logged in. Uses a private key to lock the token and prevent tampering and impersonation. The token is stored on the client in a cookie or in local storage. So again, you're going to have this thing called an authentication token, and that token is saved in a cookie. Or do you guys remember local storage from first semester? Local storage is something that we used in JavaScript, right? That's kind of the upgrade to the cookie, right? Cookies are inherently small. Local storage is something built into JavaScript, vanilla JavaScript, that you can save more information in local storage. Okay, so kind of an upgrade to the technology that is a cookie is local storage. Your token can be sent to the server, again saying that you are logged in. Again, Tony said, can they have an expiration date? Yes, they do. And again, there is a key that is very similar to our secret in bcrypt, you basically have this key that if a hacker has your key, they would be able to use software to get access to the what's called the payload. Okay, so that's going to be the 1-2 approach that we're using. We're going to use cookies and we're going to use web tokens. So to get into web tokens a little bit more, I would encourage you to take your time and kind of read through this article, Introduction to JSON Web Tokens. They are broken down. I've broken it down into here. A web token has a structure kind of broken into 3 parts. The first part is a header. Header is broken down into 2 parts. The type of the token, which we're saying is a JSON web token. This article explains the different kinds of web tokens. JSON, you know what JSON is. This is a JSON web token. There are different kinds. So in this header, we're saying, hey, this is a JSON web token, and we're using SHA-256. That's the kind of encryption that we're using. That's the information that's stored in the header. Then we have the payload. The payload is the data that we're going to encrypt. And so in this case, this payload is just a JavaScript object with keys and values, keys and values, keys and values. What we're going to store inside of our payload. Again, the payload, just a word for the data. What data are we going to encrypt inside of our cookie? What data are we going to encrypt in our cookie? That's the payload. Okay, we're gonna save and encrypt our what's called our authentication token. Right, our authentication token says, hey, we have authenticated on this website. And your signature. Again, a signature is your secret. Very similar to bcrypt, you had to have a secret, essentially a string, that if a hacker got access to your secret, then it would be a lot easier for them to decrypt your data or decrypt your payload in this case. Okay, so of course the most highly secure piece of information comes in this signature, and what this signature verifies. This signature is an algorithm to make sure that your payload doesn't change. Okay, again, I'm going to say that again. This signature is an algorithm. It's a series of steps to make sure that your payload doesn't change. And the way that I can bring this back to reality and something that we've all done as kids, we used to play the game in kindergarten of telephone, right? You guys know what game I'm talking about in kindergarten? Someone tell me what this game of telephone is.
Pass along a message and see if it changes by the time it gets back to you.
Okay, so in kindergarten, we started with the message, and maybe I would tell Max the message, and then Max would tell Scott, tell James, and it would go around the room, right? By the time it reached the last student, and you're like whispering in your neighbor's ear, right? Was the message the same or was it different?
Different.
Most of the time it was different, right? Yes.
Okay, this reminds me of I remember watching this movie, it's like Girl Talk or whatever, right?
Okay.
So one person would come and tell a story.
Yep.
And the next person would come, but they would modify it a little bit.
Yep.
And then the next person, and then it gets to the end, and then there's this whole crazy story. And it's like, bro, what?
Yeah, at the end of the day, you had a very different story than at the beginning. And that's the point. So what we're trying to make sure is with software that our message doesn't change. Okay, so by using software, you can verify hey, here's a string of bits. sent across a wire, and on the receiving end, that string of bits hasn't changed, right? And they got this public key and private key cryptography to kind of make sure that that can happen. Okay, the secret, makes sure that your message hasn't changed on the client, right? The client could edit the cookie, make changes with the data. This JSON web token, again, this is part of our security. We're securing that the information in the payload hasn't changed. And basically, that game of telephone, that the story that it starts with is in fact the same exact story, mathematically proven to be the same story at the end. The same story at the beginning is the same story at the end, and they can prove so with math, right? With a computer algorithm that says, hey, here's a string of bits, binary ones and zeros, run this check against those bits, and on the receiving end, it's the same data. Okay, so a web token broken down into those parts, right? The header, which is information about JSON web token, and this is SHA-256. The payload is the data itself. The digital signature is like saying, hey, yes, the data hasn't changed. And so if you were to ever inspect a JSON web token, it's all encrypted, like in this big, long cryptographic string, but it's broken down into 3 parts, separated by dots. The first dot is the header. The second dot is an encrypted payload. The third dot is that signature that, again, deals with the security, making sure the data hasn't changed. Okay, so the first package we talked about was the cookies package called Cookie Parser. So this is the first new package. The second new package is going to enable us to create web tokens, and that is called JSON Web Token. Right, so we're going to install JSON Web Token. Let's take a look at actually doing this, right? So here's an example of bringing in JSON Web Tokens. Here's our data that we're securing. Here's our secret. Again, this secret is something we're probably going to store in our env files. We send in an expiration on our web token, in this case 1 hour. Expires in 1 hour, and we create our token with this JWT.sign, passing in the data, the secret, and the options. So this sign takes those 3 inputs, and it creates a token. This token, and how we're going to use it, is going to have this is a JSON Web Token, and inside of the JSON Web Token, we'll have our authentication token, our auth token, saying that, yeah, we have logged in successfully. Okay, that's on the creation side. And then on the reading side, right, this is creating a token, but then to read that token, we're just using a different method, right? This is the sign method, this is the verify method, and to verify, you pass it a token and a secret, right? This is a payload and a secret in options. This is a read operation. This is a write operation. This is a read operation. Okay, again, secrets are important to kind of keep secure, of course. The above code included an easily guessable, hard-coded secret, but in reality, we need to guard our keys with care. If somebody knows our secret, is able to brute force, guess it, then they will be able to generate their own tokens and impersonate someone in our app. Again, what we're going to store is authentication tokens. So our strings should be, like any other password, our strings should be long. If there's one thing that makes a password secure, is that our strings, our passwords are lengthy. So you can use like a password generator to generate a 256 character password. There used to be the number 256 on here. I guess they took that. Well, I guess if you wanted to, here's a 250 character password. If you just use 5 of them. Anyways, you can use these password tools to generate long passwords pretty easily, and that's what we're going to do. We're going to store, instead of storing this in config, we'll store this in our .env file. So we'll create some variables to have a secret, a duration that it expires in, and like a max age for a cookie. Now, kind of going back to this, our web token, we could say, hey, it expires in 1 hour because it's using the sign method and it understands what 1H is. But going back to the cookies we had to specify in milliseconds how long they took to expire. If you go back to our cookie, creation of the cookie, we had to do some sort of math like this to say, hey, expires in, expires in 1 hour in a cookie, right? So this is expiration of a cookie versus expiration of a web token. Okay, something that we will do is store our web tokens inside of cookies. But sometimes you need to also pass your web tokens inside of an authorization header. And so we will do this where, remember, authentication is what we're talking about right now. Authorization is what we're going to talk about in the next lab. Okay? And so is the user that I'm logged in as authorized to access this route? So we may need to pass our authentication token into an authorization header to say, yes, these are my credentials, and determine whether you actually have permission into that resource. And so here we're going to be using an authorization header using this bearer format. And this is not necessarily something we're going to be doing until a little bit later, but this is just kind of looking ahead a little bit. Now that we're talking about, hey, creating users that are logged in, we also need to make sure that they're authenticated to our resources, and so you wind up sending our web tokens into authentication headers. I said it wrong again. Authorization headers. I don't think any. That's not something we'll do. Yeah. Okay, and we've talked about status codes, kind of the last couple pieces here. Let's see. Yeah, I'm going to demonstrate some of this in our next code along. So like the last couple slides, these are just things that we'll do together in our code along. The last thing I'll leave you guys with on this lecture is in regard to status codes. We've talked about status codes, we've used them, we've looked at the MDN article on status codes. The 401 status code means unauthorized, which is your authentication, meaning you have not proven you are who you claim to be, versus 403 means, hey, you've logged in, but you're forbidden. You actually don't have permissions to get to the resource, right? So you're authenticated, but you're not authorized, right? It's like in the military, there's different levels of authorization, right? Different levels of what you can do. So your credentials are valid, but you don't have permissions to access the resources. All right. So that's the end of this lecture on authentication. Again, big takeaway here. We've had a little bit of this in our apps, but our authentication hasn't persisted. We're going to use cookies and web tokens as a way to persist our credentials so we don't have to log in every time we close the browser. Sound good? Great.